Hello everyone, in this video I'm going to discuss the example for limits and continuity. The function fx is defined by the situation given where the a, b and c are constant. Kindly illustrate the situation in a real number line. So where we have the situation, we have the 2 and the 5. Kindly focus on this part where we have x less than 2. So we have the function x minus 4. Then in here we have x is equals to 2 where we have the a. Next, we have the situation x is greater than 2 and less than equals to 5. So here we have 2x plus with the b. Then finally, we have c, where we have x greater than 5. Kindly refers to a. Find the limit when x approaching 2 from the left and also the limit when x approaching 2 from the right. So limit when x approaching 2 from the left. Kindly refers to the left hand side and we have the function x minus 4. X approaching 2 from the left for the function x minus 4 and the value of y will be approaching negative 2. Continue. Limit when x approaching 2 from the right for the function where we have 2x plus with the b and the value of y will be approaching 4 plus with the b. So that is the question for A. Kindly refers to B. Use the definition of continuity to determine the value of a and b if fx is continuous at x is equals to 2. So, number 1, we have f2, which is equals to the value a. Next, number 2, since they mention it is continuous, so meaning that limit when x approaching 2 from the left for the function x minus 2 is the same limit when x approaching 2 from the right for the function 2x plus with the b. So from here, we have negative 2 equals to 4 plus with the b. So b will be equals to negative 6. So as we all know, since they already mentions that continuous, so limit when x approaching 2 for the function fx, the value will be approaching negative 2. Why negative 2? Because focus on the left hand side. If we substitute the 2 from the left and we will have negative 2. Then we can say here the limit exists. Step number 3. Since they mentioned that it is a continuous, so f2 is equals to limit when x approaching 2 for the function fx, the value are the same. So from here, a is equals to negative 2. Continue, C. Show that if limit when x approaching 5 for the function fx does not exist, then c is not equals to 4. Is the fx continuous at x is equals to 5 when c is not equals to 4? So, they mentions that limits when x approaching 5 does not exist. Limit when x approaching 5 from the left. For the function, we have 2x. So, previously, we already find out what is the value for b, which is negative 6. So, if we substitute the 5, and the value of y will be approaching 4. Next, continue. Limit when x approaching 5 from the right for the function c. So question asks us to show that limit does not exist. So meaning that 4 cannot be equals to c. If the c is equals to 4, then the limit when x approaching 5 for the function fx will be exist because the value are the same. So for this case, c cannot be equals to 4. So we already shown the situation. Continue. Is the fx continuous at x is equals to 5? So, step number 1, f5. So, by referring to the situation, and we'll have 10 minus the 6 because of the b is negative 6. So, f5 is equals to 4. Second step, limit when x approaching 5 from the left for the function fx, the value of y will be approaching 4. Limit when x approaching 5 from the right for the function c. So refers to the question. The question mentions that c cannot be equals to 4. So limit when x approaching 5 from the right c, then we will have the value c. So limit when x approaching 5 from the left for the function fx. Limit when x approaching 5 from the right for the function fx. So question mentions that the c cannot be equals to 4. Means that other than the value 4. So if other than the value 4, meaning that these two values will not be the same. So limit when x approaching 5 for the function fx does not exist. Then we can say that fx is discontinuous at x is equals to 5. If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.